right, so this is for people who needed help with the last three questions on lab. I'm gonna try to adjust this here a little bit. There you go. So number one, why does the excess water need to be removed before you place the item in? So let's just say, okay, you have your overflow can, like so, okay. But let's just say there is 10 mLs of water in there and you don't notice. And then you put your item in. Now what's going to happen? Well, water's going to come out, right? And then you're going to measure this in a graduated cylinder. The reason you need to take out the excess water is because it's going to think that this 10 mLs is part of the ball's volume, but it's not. So like, let's just say the ball's volume is 20 mLs. Let's just say it's supposed to be 20 mLs. You're going to think it's 30 mLs because you didn't take out the extra water. So that's why that one is there. What makes object E, the flask, more challenging? So these are similar. Okay, so they're similar. So what makes object E more challenging? At the end of it all, it's really this air pocket. So I'm going to illustrate it right side up. Okay. So let's just say you have the water, right? And you put the flask, and it doesn't matter. So like the way you put it doesn't matter. So here again, the air pocket is the problem. Now, what must you account for? Okay. And this is part D, is you have to account for the extra volume of air. So just the answer to number 2 is just air. And then what must you account for? It's the extra air volume that it adds. So when you put this in, it is a common, and I'll try to do this in different colors, so maybe this will help out. So there's air inside, right? And when water spills out, so let's say there's this opening and water spills out, it is a combination of the glass plus the air pocket. So like all this extra volume is air. This is why when some of you were giving me a volume of like 150 mLs plus, I knew that this was wrong. Why? Because it's too much. What you were including was you were including the glass plus the air. So what you had to do was you had to account for the air pocket on the inside. You had to find a way to subtract it. And there's 2 ways to do that. One of the ways, and this is the way most people did it, is they took the flask. Okay, it had empty space. They put water inside. So they put water. All right. And then from there, they figured out, okay, well, how many mLs of water are in there? And that is equal to the number of mLs of air. So actually this is water. And this is air. Like that. Okay. So inside, so let's just say that total was 150, but you found out that, and I'm just going to throw a random number, but 110 mLs of water fit in there, which means there's 110 mLs of air. That means that out of this 150, 110 was air. So that means that the glass part of it must have been 40 mLs of glass. So I'm just throwing this out as a fake number. So it's not a real number. And it doesn't matter if you put it in the other way. So like if you put it in the other way, the flask was too tall. So here's the water level. And your flask basically stopped right there. And it's kind of designed that way on purpose. And what people don't get is, look, the air pocket is under the water. Okay, so that air pocket is under the water, and so is the flask. So you run into the same problem. When it spills out water, it's because of this air pocket under the water and the glass. You have to find a way to subtract it. And that's why most people measure how much fits in here. And that's how much air there is. Okay, so that takes care of the last 2 lab problems. Kind of an over explanation, but you're going to need it for density. Trust me, because you're going to face this problem again. So why do we need to remove excess water is if you don't, you're going to add extra volume that is not there. What makes object E more challenging? The air pocket. What must you account for? Subtracting the air pocket out of your total volume just to end up with the glass.